proteins without having to rely on tethering of the protein to a larger polymeric bead. And of course, the final application of surface plasmons is in molecular sensing, because surface plasmons are sensitive to the refractive index of their surrounding environment and also to the charge. They can sense things like redox reactions or gas absorption. Now, when I started my position at Stanford, I really liked these applications, but one thing that occurred to me is that most applications to date have relied on somewhat larger nanoparticles. I realize this may be a bit of an oxymoron because we're already dealing with nanoscience. But one question my group had is, what happens as plasmons become confined to even smaller spaces where a lot of the unusual effects that we find in quantum mechanics may start to impact the far-field optical response of plasmonic particles? And then a second question that we were struck by is that most applications to date rely on electric resonances. And in fact, when I was motivating or introducing you to surface plasmon particles, I just talked about how the electric field of light drives the electrons in the nanoparticle. But what about the magnetic field? Can we create a material that responds strongly to the driving magnetic field of light and therefore has a magnetic permeability that's different from one? This thing gives us the opportunity to create new metamaterials that have a tunable index beyond the library of naturally occurring materials. So rather than the Dr. Seuss poem, here's my more formal outline. In the first part of my talk, I'll show you what happens when plasmons become quantum confined. Then I'll show you how we can use an electron beam to steer groups of particles such that we can get them close enough where electron tunneling between the two particles impacts their resonances. And then in the last part of my talk, I'll skip over to magnetic plasmons, so groupings of particles that exhibit a strong optical frequency magnetic response. Okay, so starting with the first topic. A lot of people like to ask me, why was I interested in looking at small particles to begin with?